when we add or subtract fractions, we have to make sure that we have a common denominator. So, you know, I'm going to start with a simple-ish example, just going back to like a numerical fraction, okay? So here's the way I approach these numerical fractions, and it will mirror a successful approach to the algebraic fraction. So I start by factoring the denominators. I don't care about factoring the numerators yet. In this case, of course, 5 and 7 are primes, so they don't factor anyway, but we always just at first start out not really caring that much about factoring the numerators. I'm going to factor the denominators. So 2 times 3, 3 times 5. Then what I do is I start, and I'll keep my focus just on the first denominator, 2 times 3, and I say, look, are there any factors over here in the bottom that are not present in that first fraction? And yeah, we could see, oh yeah, it's missing a 5, right? So what I want, in order to make sure that it has the same factors, I want to multiply by 5 here. I'm allowed to do that as long as I also multiply by 5 up top. All I've done is multiply that fraction by 1, by 5 over 5. And then I turn around and I do the same thing with the other fraction. Any factors in the first denominator that are not present over here in the second, and that's the factor of 2. So I want to give this a factor of 2, which I'm allowed to do as long as I also multiply by 2 up top. So now my common denominator is, let's see, 2 times 3, 6 times 5 is 30. So now I'm going to write this as a single fraction. I bring over the common denominator. Up top I've got 25 plus 14, right? So you just do the operation, in this case addition, on the numerator. So we have 39 over 30. And then the last thing you want to do is make sure that your fraction is reduced. A lot of the time it might not, you know, there may not be any common factors, and what we have is already reduced. In this case, we actually can reduce because we can factor out a 3 from the top and the bottom, and we get 13/10. Alright, so let's see this at work with algebraic fractions. In example 115, our denominators are already the same, right? So we don't have to worry about getting a common denominator. We're just going to bring that common denominator over and then do these operations on the numerator. So I've got b plus 1 and then minus. Now be careful here. I'm subtracting that whole numerator, so I'm going to put it in parentheses. I will say about 1,000,000 times over the course of this semester or this term, you know, be careful with your signs. Sign errors are some of the most common types of errors to make. You might see me make one once or twice, and usually I'll catch myself and correct it, but they're easy to make. So now what I need to do is simplify the numerator, right? Because I'm adding a bunch of stuff together and I want to combine like terms. So I'm going to distribute that negative, being careful with my signs. So now we have negative b plus 2 over ax. You could leave it like this. Some people like to start off with a positive term, so some people might choose to write this as 2 minus b over ax. Either is fine. Alright, in this next example, we'll see that the denominators are not already equal, so we need to get a common denominator. I'm going to begin just by rewriting this problem. I'm going to factor those constant factors, break them down to their prime factors, make it a little bit easier. So starting at this first denominator, I'm going to scan the other fractions, figure out what factors do the other denominators have that are not present here. I can see that it needs to pick up another factor of 2. It needs to pick up a factor of a to bring us to that a cubed. And it needs to pick up a factor of b to bring us to that b squared that's in the middle. Moving on to the middle fraction. This needs to pick up all the constant factors. So 2, 2, and 3. It needs to pick up an a squared. And it doesn't need to pick up any b's because it's already at the b squared. And now for the last guy, this needs to pick up a factor of 3. It doesn't need any a's because it's already got a cubed, but it needs a b squared. So 3b squared. Now all denominators have all the same factors. Our common denominator is 12 a cubed b squared. And now I'm going to bring down these products that we have up top, and as well as the operations between them. So our first product is 10ab. We're going to subtract the next product, which is, let's see, 36a squared. And we're going to add the last product, which is 3b squared. And that's as far as we can go here. Okay, let's try another one. Example 117. Now this time we do have addition and subtraction happening in the denominator. They are both factored though already, right? So we always start by factoring, make sure our denominators are factored. These are already factored. There's no factoring to do, but it is imperative that we understand that x plus 1 and x minus 1 are two totally different factors. They have no factors in common. So when we write this out and we begin working on this, knowing that x plus 1 and x minus 1 have no factors in common, that forces us to conclude that this first fraction has to pick up a factor of x plus 1 on the top and the bottom. And the second fraction needs to pick up a factor of x minus 1 on the top and the bottom. So now that gives us this result here. Our denominator is x plus 1, x minus 1. Now, I always leave the denominator factored. You may choose to multiply it out, but it doesn't get us anything, and in fact can sometimes make our lives harder. So I urge you to leave the denominator factored. Up top, what we have to start out with is a times x plus 1 plus a times x minus 1. Now, the reason we're leaving the denominator factored is because, well, it is factored. It is the product of its factors. The top is not factored. The top contains some products. I could see some multiplication happening here, but it's really a sum of two things. So you always have to multiply out the top. You have to multiply out the things, the products that appear in the top, combine like terms, and then simplify as much as you can. So again, the denominator I'm going to leave as is. Up top I have ax plus a plus ax minus a. I can see that the plus a and the minus a will cancel, and then we have ax plus ax, or 2ax, over x plus 1, x minus 1. Well, let's try again. Here's another one. We have, we can see that the denominators are not the same. And then also we might notice that first denominator will factor. So before I do anything, I'm going to rewrite this by factoring this first denominator. That is a difference of squares 2x plus 1, 2x minus 1. Now, I just want, before I continue, I want to highlight, here's a 1 minus 2x, and there's a 2x minus 1. They're virtually the same. They're almost the same. In fact, they're just off by a sign. So what I'm going to do is I'm going to rewrite this fraction, the middle fraction, as a negative 2x minus 1. And then the 1 plus 2x, that is the same as 2x plus 1. There's no negative to take out. They're just, the order of addition doesn't matter. Now, I'm going to go a little further. Here, I'm really subtracting a negative, right? When, this fraction overall here is a negative. I've got a positive over a negative. So I'm subtracting a negative, and I am going to rewrite that as an addition. Just trying to simplify things as much for myself as I can before I go much further. Okay, so now we set about trying to add factors that might be needed. The first fraction needs nothing, right? There's nothing present in the other two denominators that's not already present in the first one. The second fraction needs a factor of 2x plus 1. The last fraction needs a factor of 2x minus 1. Now I'm going to pull down these products. So I've got 4x to start with, bring down the plus, in the middle 3x plus 1 times 2x plus 1. Bring down the plus, and then 2x times 2x minus 1. Okay. Now, the denominator I leave factored. It is written as a product of its factors. The top is not written as a product of factors. I can see that we have some multiplication happening, but overall, I'm adding some products together. So we're going to expand those products, combine like terms. Let's see, so this is going to be in the middle 6x squared. Let's see, 3x plus 2x is plus 5x, and then plus 1. In the end, I'm going to distribute the 2x, so I got 4x squared minus 2x. Now I'm going to combine like terms. So we have 10x squared. Let's see, 4x and 5x is 9x minus 2x is 7x. And then plus 1. And we have 2x plus 1, 2x minus 1. And then we always want to check and make sure that we are reduced. 10x squared plus 7x plus 1. Let me try. Let's see if that will unfoil. If it does, we probably need a 5x and a 2x. It's got to be a plus 1, and the middle is positive, so plus 1, and that does factor. That gives us the plus 5x, that gives us plus 7x in the middle, and we end up with a common factor that we can reduce. So this is 5x plus 1 over 2x minus 1. All right, so now we're going to finish this section working with complex fractions. So a complex fraction is a fraction that just has a fraction inside. It's like fractions inside fractions. A fraction that has fractions inside is definitely super extra not simplified. And there's a couple of ways to approach it. One approach is simply to deal with the numerator and denominator on its own, kind of treat it as a separate problem, write each as a single fraction, and then say, oh, I'm dividing these two fractions, and then we know how to divide fractions. Another method, which I kind of like, which I find a bit more efficient, is simply to identify the least common denominator of all the little fractions that appear in the big fraction, and then multiply the top and the bottom by that LCD. So if we take this approach here, I'm going to start by factoring the denominator of this top here, so that'd be an x plus 1, x minus 1. Nothing to factor over here. Now the LCD of all the fractions that appear in the big fraction is x plus 1 and x minus 1. I need both of those factors. So I'm going to multiply the top and the bottom of the big fraction just by the product x plus 1, x minus 1. And this is going to distribute. I'm going to distribute this to all the terms that appear, just two terms that appear in the top and the bottom. So up top, I've got the product x plus 1, x minus 1, plus, now when we distribute it to this fraction here, right, so I'm talking about this step here, where I take this product and I distribute it to this fraction. It's going to cancel out those denominators, right? This is, and I'll write out the term, but like you might, a lot of people might skip this step, and you might find that you do after you get a bit of practice, but we have the fraction 1 over x plus 1, x minus 1 times x plus 1, x minus 1, which I'm going to write as over 1, just to emphasize. So that's on top. We could see that these cancel, and so we're just left with 1. On the bottom, when I distribute it to the 1, I've got x plus 1, x minus 1, plus 1 over x minus 1 times x plus 1, x minus 1 over 1. Now, not everything cancels this time, but that's fine. All I need is everything in the denominator to cancel, and that does happen. So let's see what we got left here. Up top, I've got the product x plus 1, x minus 1, and then plus 1. In the bottom, I've got the product x plus 1 times x minus 1 plus x plus 1. Now, hopefully, when you look at this, you're telling yourself, I definitely cannot factor or cannot cancel the x plus 1, x minus 1 that appears in the beginning of the top and the bottom of this fraction. And the reason that we can't is that that's not, those are not factors of the whole fraction, right? They're just a product that's part of a sum, right, that we're adding. So we have to be careful here. What we're going to do is expand. Let's expand these products. X plus 1 times x minus 1 is x squared minus 1. And then we have the plus 1. On the bottom, x squared minus 1 plus x plus 1. So what we have up top is x squared. What we have on the bottom is x squared plus x. And we can factor this a little bit. We could take out an x from the bottom. And then we could cancel a factor of x. So we end up with our final result of x over x plus 1. Okay, in this next one, again, the first step in simplifying a complex fraction is just recognizing when you're looking at a complex fraction. We defined a complex fraction to be one where we have fractions inside of fractions. So when we look at this, it might not be obvious, but negative exponents are fractions. And trying to hide fractions within fractions by using negative exponents will never work. It's never simplified. So the first thing I'm going to do is write it as a complex fraction that I know it is. X to the minus 1, that's 1 over x. 2y to the negative 2, that's 2 over y squared, right? The negative 2 exponent is only on the y, so the 2 stays up top. On the bottom, we've got 1 over x minus 2 over y squared. Now if I scan the little fractions that appear in the big fraction, the LCD, the least common denominator, is x times y squared. So I'll multiply top and bottom by xy squared and distribute. When we distribute, there's going to be canceling. So 1 over x times xy squared. When I distribute to that first term up top, the x will cancel with the x on the bottom, and we're just left with y squared. When we distribute to the second fraction up top, the y squareds will cancel, and we're just left with 2x. Notice now we have no fractions up top. Right? This is what is accomplished by multiplying the top and the bottom by the LCD. On the bottom, it's the same products we're finding. It's just that we are subtracting instead of adding. And actually, see, I just made a little sign error here. Up top, that's an addition, not a subtraction. On the bottom, it is a subtraction, so this will be y squared minus 2x. And that is as far as we can go. The y squareds don't cancel, the 2x's don't cancel, because we cannot cancel over addition or subtraction. And there's our final result.